Let's make a start. So thank you very much for coming along today. I'm Paul Boocock. I'm one of the heads of engineering at Snowplow, and I run the group that is responsible for the SDKs, the client SDKs that our customers put inside their applications to track event data, and also the data models, which is what we then do with that raw data that comes out of those SDKs, and that's what I'm mainly going to talk about today. And then we also are now building a new sort of bit of product that we're calling a data product accelerator. And this is all about helping you get sort of to success a little bit quicker with Snowplow, giving you sort of a recipe as such to follow with long-term ambitions for those to sort of be deployable assets. So that's me. And my Snowplow experience. Been working in data for a little while now. I've been at Snowplow for 3 years, so I've been doing this for a little bit of time. But yeah, I'm going to try and take you through some of the learnings today that we've made. We've also been building these SDKs, and then some of the learnings we've made when we've been trying to model the data as well in the various data warehouses. So what are we going to talk about today? Well, we will first start with an introduction for Snowplow. This is as sales pitchy as it'll get today, I promise. But I think some of it may make a little bit more sense if you have a rough idea of what a Snowplow even is. And then we will dive in to looking at our SDKs and then our various data models that we've got and how we think about those. So let's dive straight in. What is Snowplow? So basically, Snowplow is a data collection pipeline. It runs in the cloud. It runs in AWS and GCP, and it is a system that lets you collect event data from a variety of places. It has a validation and enrich step in the middle, which I'll touch on a little bit later, and then it lands that sort of validated and enriched data in various supported data warehouses. It also supports event streams, so you can consume in real time. Then it also supports forwarding those events in real time to a few destinations. The bits we're going to focus on today are sort of these two end bits, which is the bits that I'm most interested in as well. So we're going to look at how we generate these events and the SDKs that we build and how we build them. And then what we do downstream of that to aggregate and model that data. So Snowplow is a very generic platform, I should probably add. You can sort of see that right at the end. So the way these models get consumed is like almost an unbounded list of things. We see a real variety of use cases, from classic BI use cases, which have sort of been our bread and butter for a long time, to more advanced use cases like AI and machine learning style use cases, as well as now sort of forwarding that modeled data into various downstream tools like product analytics tools, ad platforms, things like that. It's becoming increasingly common to not want to run various pixels and things like that on your website, but to capture them, model them in the warehouse, and then forward them on to various tools, that whole reverse ETL approach that you may have heard about. Right. So that's Snowplow in a 1-minute nutshell. Let's quickly dive into to our trackers. I'm not a big fan, I'll start there, with the name trackers. I think it sort of makes them sound a little bit nefarious, but they're not really. Ultimately, they're just SDKs that allow you to capture event data from whatever platform you're on. However, before I can really talk about some of the power of our trackers, I need to go on a little bit of a detour to talk about JSON schemas. This is fundamental to Snowplow. Like the core of Snowplow is really built around a JSON schema, and that's how we define what an event looks like, as well as the additional data that can be attached to an event. So in Snowplow, data looks a little bit like this, and we have this concept of an event. And there's a number of default properties that are in what we call the atomic events table. This is a big, long, wide table of various properties that Snowplow collects. Things like various user IDs, various timestamps. On the web, you'll see things like page URL in there, and you might get marketing campaign information. All this is like fundamental default tracking. Beyond that, you can then add all this custom stuff, and that can be like whatever you want. It can effectively be an unlimited list of things. And these are all strongly typed and they're all validated properties. And we'll come on to how we do that in the next slide. But then a little bit of the magic of Snowplow comes with these entities. So the sort of the event thing's relatively common. I think we can all probably imagine how we want to capture an event. And then we want some custom dimensions on that event we want to track. Entities are a little bit different in that they basically allow us to create these objects of data, and we can attach this entity to any type of event. So we can make these business objects that have consistent properties in them, no matter the event. So this might be a button click as an event type, and this looks like a book or something, this entity. But there's other types of events that happen on our website. They might be purchase events, they might be add to basket events, whatever it could be. You could have different types of events, but they would all have the same entity attached. And then when it comes to looking at that data in the warehouse, you're going to have a consistent entity. Your data analysts, scientists, whatever, they all know exactly what to expect when they're looking at the column that includes this entity in it, because it's always the same. So we define these objects, both the custom dimensions of your event and also all of the custom dimensions of your entities through JSON schema. I should also add you can attach multiple entities to every single event. So whilst you can have one event, it could have 10 entities attached to it, all describing the context of where that event occurred. So as an example here, this is an event. This is a click event that someone's created. And you can sort of see we have this self block. We call them self-describing JSON. And the self block describes the vendor of the event, the type of event, the format, which is always JSON schema, and the version, which is quite important, as you'll see in a minute. We then have a list of properties to every event. And you can specify a long list of properties here with type information as well as validation information. All this is taken into consideration when you track the event, and then inside the pipeline, it all gets validated against this schema itself. But you can also evolve these schemas as well over time. And this plays in. So when you track your event, you say I'm tracking a click event, but you also say what version of the click event you're tracking against. This informs the pipeline that this event should have a button property with either a string or it's a null in this case. There's no required, no requirement to specify this, and some index, which is an integer, again, optionally. And then what you can see is we've got these version numbers. Now, what the Snowplow pipeline does, something I'm not really going to talk about today, but it's quite cool nevertheless, is it can work out from schema 100 to schema 101 what needs to change in the warehouse as well. So it can migrate your tables automatically as you track new types of events. So as version 101 of the schema gets rolled out and events start to land, what you'll start seeing landing in the warehouse will suddenly be a column that now has button and index available in it, not just button, which is a nice little feature for the analysts downstream. They can trust the data that's landing as well. So this is sort of what it then looks like in the warehouse. So you have your default fields. There's 130 of those. Event name being one of them. That looks like click. And then you have a column which describes that Acme click version 1. So that one's the major version. So if you went up to version 2.0.0, it would generate you a new column if it was a completely breaking change. And then you get your object in your column data, which you can parse using the various JSON tools in the warehouse. But you can see here, we've got a version, another click that was tracked against 101. So we can see down here that this is now got this index, and that's landed in the warehouse fine because we've migrated this column to have this optional index field. So in the strongly typed warehouses that want this information, so you can deeply understand what's in each column, we can migrate that. In the less strongly typed warehouses, your snowflakes of the world, and this would just be like a variant, and we'll just land whatever JSON object in there that we can. So let's move on to the tracking SDKs. So with that schemed approach in mind, there's a really nice sort of feature that gives us. We basically get these strongly typed objects. Now we've defined a whole host of these ourselves, like out of the box ones that just work. But you can also make your own. So that leads us to sort of some various points really that we can make decisions on in terms of like how we would build our tracking SDKs. Some of them might be popping into your head already around sort of maybe how we could auto-generate trackers, or if that's a good choice or not. And that's sort of what I'm going to touch on today. But at a base, I apologize for those of you that aren't familiar with class diagrams, but our trackers look a little bit like this. So they pretty much all have this like Snowplow interface, and we allow people to create multiple instances of trackers. Each tracker has a different set of properties, effectively, or configuration, I guess you could say. And so you might have one that tracks PII, you might have one that doesn't track PII, and then depending on the state or the consent of that user, you may choose to use one instance of a tracker or the other instance of a tracker, just as one example of how that gets used. The tracker object then basically has control of these three common concepts, what we call an emitter, a session, and a subject. So the subject's the most obvious one. That is the person that this event is in relation to, or thing. It might not be a person, it could be a machine, it could be IoT device, whatever it might be, whatever the subject is. The session, that's typically stored somewhere. So this is a bit more client oriented, and I am going to touch a little bit later on the difference between like server-side tracking and client-side tracking. But we do all of our sessionization client-side rather than in the warehouse. Some places or some tools will try and do sessionization in the warehouse side. It's quite tricky to do that, and you'll see things such as Google Analytics that reset sessions at midnight, or at least it used to, and those sorts of decisions. Perhaps, I can't be sure because we don't know what's inside the black box, but perhaps oriented around the fact that sessionization is done differently. So we don't have those typically what I've seen as limitations because we're doing that all client side. So we're very much in control of when a session begins and when a session expires on the client. And then we have this emitter. And our emitter object basically is a configurable sort of instance that describes where events should go. So the most important thing really is the URI and where we're going to send the events to, but there's usually quite a lot of configuration that goes into here as well. And I'll touch a little bit more on why that is later. Our more advanced trackers then have what we call an event store. And so we buffer the events locally, and then we try and send them through some sort of HTTP client to a Snowplow collector. Once we get a response back from the collector that all's good and that we've happily received that message, we'll clear it from the event store. But if we don't get that back, maybe there's poor network connectivity, maybe this isn't running on a mobile device, maybe the collector's down for whatever reason, then we can store that event locally, and then we can queue it up and retry it. The more advanced trackers, again, have different retry policies. So you can have backup and retry. You can throw them away when you get to a maximum number of events so that you don't run out of memory on the device, various other tweaks that we can make as well there. But if we go back to my earlier description of the event types, there's built-in ones that we can see here. So sort of like a screen view event is based around a schema, and it's got two properties, a name and an ID as an example. So this is for a mobile phone device. Typically, that's what we think of as when we're tracking screen views. And that's sort of built in to the trackers. You'll just get that out of the box. But what you also get are these self-describing events. This allows you to track any JSON against a particular schema. So you'll see a self-describing JSON blob, which is a schema, and then the associated data. That corresponds back to that JSON that I showed, that JSON schema that I showed you earlier, allowing our customers and users, it's an open source platform at the end of the day, so not everyone's a customer, to track whatever they want here with that self-describing JSON. So but what we also find people then do is they take these base classes and they extend them. So they make their own whatever event, and it extends self-describing JSON. And then they have their own strongly typed object that defines what it is. But under the hood, it's sort of still a self-describing JSON that gets tracked by the Snowplow tracker. So that's sort of the core makeup of the shape of inside of a tracker. Hopefully you found that a little bit useful, just to see how we typically think of them. And then quickly, so we went from being a web-only platform a long time ago to a platform that sort of wanted to be more than the web. And then web's an interesting platform, right? I'm sure anyone that's ever done any web development will know that the web is probably broken, but also is just a pain to develop for. You've got multiple browsers, you've got versions of browsers that break compatibility occasionally, or that have slightly poor backwards compatibility, or you have terrible old browsers like that you still need to support. So that poses its own unique challenges on the web. But when we start thinking about other platforms, some of those challenges go away or they change. So we've toyed around with the idea of automatically generating trackers. And if you see here on the left, this is a list of all of the trackers that we currently have, I think. And we've got the classic web one. It's very different, in fact, though, the web one to all the other trackers. The mobile ones are a little bit different again. So they feel a little different in the sense of like, they're still client trackers. So there's a lot of like automatic subject tracking that's happening in them. But that's sort of, and like automatic screen view tracking and things like that, which is sort of similar to the web, where you've got automatic sessionization, automatic user tracking, you've got page view tracking built into them. But then when we get down this list into the ones that are just sort of other programming languages, I guess, they become much more generic. And they're probably much more tempting to auto-generate. So we've explored tools like QuickType, but it's never really panned out for us. We've always lent ourselves towards handcrafting SDKs. So I sort of see there being really two options, handcraft or auto-generate. All of our trackers are currently handcrafted. This has a huge benefit, as hopefully they all feel right in their platform like that they're working in. So if you're a Rust engineer, you get a Rust tracker, it feels like a Rust SDK. It doesn't feel like something that's been automatically generated by a tool. I don't feel like that really gives the experience that we'd want in particular languages that need to feel like they fit in that language. You know, anyone that's like used like a Java alternative like Scala or something, you know, trying to use like a Java library inside Scala is not particularly nice. And I fear that that's what we'd end up with if we auto-generated all of our trackers. However, I think there's space here for us to continue down this auto-generation thing to make the life of the tracking engineer a little bit nicer. So I've put, can we do both? What we're exploring at the moment here is if I go this way, go back to this. I think this bit on the left of the diagram, the core tracker, was similar across many platforms, like the core concepts are similar. The interfaces can feel a little bit different so that they feel right for the platform that we're working with. This bit on the right, however, this feels very auto-generatable. If we know all of the custom schemas that you've defined, we can take that and we can automatically generate all of these classes that you need that are all sort of extending away from self-describing JSON. So that's what we're exploring at the moment. It's shown some early signs that look good, and it creates a nice experience for engineers because then they know exactly what objects to populate. Then they can just track them in the tracker. You just got a strongly typed object, fill it up, pop it in the tracker, done, sent off to the collector. And that's quite a nice experience for the developer then. So we're exploring that more and more. Something else I've touched on already a little bit is this idea of server versus client SDKs and how they differ. So if we go back just quickly to this diagram again, what the bit on the left, shows is that core tracker. This doesn't do anything. This is really just a set of functions that you sort of interact at the top level, and then you get a tracker out of it, and you call track, pause, and resume, and you give it one of these objects. That's sort of where you're at. But under the hood, the trackers do differ quite a lot in behavior. So a server SDK is typically very configurable, but also quite lightweight. It doesn't do a huge amount of automatic clever stuff. But we allow a lot of configuration in them because we know how different everyone's server setups can be. So you might be working in a .NET application, C# app, and maybe you've got really tight memory constraints. So maybe you don't want the tracker buffering thousands of events if the collector's down. Maybe that creates a memory constraint that you're not willing to deal with. So you might want to turn off the buffer. Or maybe you want to limit it to just, I don't know, 100 events. That's not a lot of memory. And we give people those bits of configuration, and they're particularly important server side. And there's also other little constraints, like you can't really write to disk on a server. So we need to give people to do it all in memory and not always write to a disk. Whereas on a client SDK, the constraints are different. We can probably write to some sort of file store, an iOS device, an Android app, whatever. They all give us an opportunity to write somewhere. So we can store things a little bit differently. Same in the web, we can write to local storage, and we've got a few megabytes of memory that we can write temporary events to in there before we send them on. But also the big difference here is in the client SDKs, we've got the opportunity, partially because it's coupled to a particular user or a particular device, we get the opportunity to do a little bit more automatic tracking. So we can identify that user for a longer period of time. We can do, like, use cookies classically to do things like that. We can use local storage on the web as well. On a mobile device, we can write things to the on-device memory to keep track of the session and to keep track of the user. We can even, if permissions granted, get things like IDFA tokens on iOS devices and track those as well, because there's extra identifiers available to us on some of these platforms. So there's a few things that we make sure our client SDKs also have on top of that classic sort of server, underlying server piece. So they're all sort of like this, but for instance, in a client side SDK, you typically don't interact with the subject at all. It just automatically is all populated. And you could overwrite it if you want to, but you don't really care about the subject object ever. It just happens to all be there. Because in the browser, we can get the color depth, we can get the user agent, we understand the language, we know the screen resolution. The browser can just tell us all of that information. Server side, you've got to fill all that stuff up because we don't know what's on the other side of that server if you're tracking through your server. All of this cool stuff leads to a huge amount of configuration challenges. So if I just show you the web tracker configuration, like these are the various objects, the various properties that you can configure when creating a new tracker. And some of these make absolutely no sense unless you deeply understand either the web or how Snowplow trackers are architected. This is a big problem because no one knows how to use nearly all of these or what any of them mean. You've got to then rummage through the docs, go and read docs pages, and that's not the experience we really want people to have when using an SDK, and we want to make it much easier. But you can see some things in here. You can configure all the cookie settings that you want to use, quite webby. There's things like buffer size, max post bytes, like you might not really appreciate what that is. Something called a cross-domain linker, something called anonymous tracking that has various different modes enabled in it. There's some flags, like who knows what reset activity tracking on page view does unless you go and read the docs. So this is pretty tricky. And a big challenge really for us that has been, how do we make our SDKs easy to use, but still allow people with weird use cases? Like Snowplow is a really generic platform, so we're always thinking about like the weird use case. How do we support those people? And really the answer has been sensible defaults. So that's all you need to do when you new up the JavaScript tracker in nearly every circumstance. If you do that, you're going to get good tracking. If you want to go wild and configure all sorts of bits and bobs, you're probably going to break it, but you can do it if you want and you know what you're doing. But on the whole, you just do this. I'm not going to waste time talking about why the same site flag on a cookie is lax by default, but it's really for legacy reasons. So maybe when V4 comes along, we can bin that one off as well. One of the reasons we end up with all of these configuration options is we start like this, and then someone opens a GitHub issue, and we're like, oh, that sounds like a good idea. So we added another configuration option, and then we end up with that. So ensuring that every single one of these has a really sensible default that will just work out of the box is really important to us. All right, so I've got about 10 minutes left. And I want to just whip through what we then do with all of that data on the other side of the platform. So it's cool to be able to create all these strongly typed objects, to be able to track them all, and then to have them processed by this magical Snowplow thing. But then that data, often billions and billions of rows of data, we see individual Snowplow pipelines tracking. So one company tracking billions of events a day into their warehouse. What do they then do with that data, and like how do they make it useful? Because that individual event level data is sometimes useful, but often not the most helpful when you're trying to do your analytics in the warehouse. So we have this concept of data modeling, which fundamentally is a process of, I'll just read from the slide, of taking, of using business logic, so logic that's specific to your company or your domain, to aggregate and transform that raw data that's coming out of those various trackers that you've collected. So really for Snowplow, we don't think anyone really should really be querying the raw events table. There will definitely be some use cases for it, but that raw events table is massive for starters in many use cases. And it's also quite complicated to query and to actually get the answer to your question that you often want. So as an example here, you might see something like this. You've got your raw events, and then you've got your page views or maybe your screen views if you're on mobile. And that actually might only be, looking at your raw events table, it might only be 20%, for instance, of your table size. So as you do that aggregation, you've got two big wins here. One, you've made your table that you're actually performing your analytics against much smaller. So therefore either cheaper or faster, depending on the warehouse, to query, or maybe both. And also, as you do this, you can aggregate the information up a level to create more helpful sort of stats. And I'll show you an example of that in a minute. Similarly, we then aggregate up again to the session level. So then we've got an even smaller table. So now we can start reasoning about our sessions. And then probably the most important table for many is aggregate that up into a users table. Again, an even smaller table, but a really valuable table. So we can actually look at how many users have we had on our website, or how many users have visited this page, or returned, or come from this marketing campaign, or whatever it might be. Again, user identification really useful for ad platforms and such for forwarding on. So what this gives us now is this end-to-end approach. We have this clean, structured data that we've tracked, schema data, we've tracked it with our trackers, and you see how we build those, and that lands in your warehouse. You've then got this consistent business logic, defining your data model, so everyone can see exactly how we've got to that table and that metric that's in that table. Or you can at least ask, and at least it's consistent, which gives us more time to build the things on top of that model data that you want to see. I should add that model data also is completely configurable. So as you add custom information in there, you add your own entities, you can extend that and bring your own logic to do whatever you want to do. So let's have a quick look at the raw data when it lands in the warehouse. It'll look a little something like this. So you've got all your out-of-the-box fields, you've got your event types, so we might have some search events, some checkout events, some transaction events in a classic e-commerce website here. We've then got some entity information. So you'll see this user entity is attached to both the search events, show here, the checkout event here, add to basket, and also well, it's not on the transaction. We've lost the user at this stage. Maybe it's been done server side, so we've lost the user information. But we can tie it back to the transaction because we've got the transaction action here. So you can sort of see by having these consistent entities, we can see that just move zoom out of the way. We can see that this transaction was the same one that was started on iOS that then completed server side. Obviously, as the transaction went through on the server. So this is sort of a very common flat events table that you might see. And similarly, I won't touch on that. I think that's a bit of a duplicate. But where some of the real power comes from here is when we start thinking about how we incrementalize this model. So there's two problems that we see. One, we want to aggregate some of this, and two, we want to aggregate it but not rebuild all of the aggregations every day. We're dealing with billions of rows of data flying into these warehouses. We cannot drop and recompute these tables hourly, daily, whatever you want to do, it very quickly becomes impossible to do or way too expensive. So basically, we look at this consolidation concept, the same thing I've just talked you through. It's just a slightly different diagram. And this basically gives us these common levels of aggregation, but also gets rid of any repeated join logic as well that you might be seeing. So we give you as a user, whether open source or a paid customer, you're going to get this out of the box. Same, there's a mobile version, and there's a few other ones coming as well, like an e-commerce one that we're building at the moment. But you can also extend it with your own event types and your own levels of aggregation as well. So as an example here, we take the raw events and we aggregate up into page views, something we call activity tracking, which gives you engagement stats on the page view. So when you load a page, you get a page view at the start, and then we have something called a heartbeat. And this happens in the trackers. It's configurable, but let's say every 10 seconds or every 5 seconds, if the user's interacting with this page, clicking, scrolling, whatever they're doing, and moving their mouse around on it, you'll get a heartbeat event that fires. So there's two things you can do with this information. You can either have a moment in time where you've decided if there is more than 2 heartbeats, or maybe even just 1 heartbeat on a page view, that's classed as an engaged user on that page. Because you've seen a heartbeat event, you know that at least 10 seconds has passed where some activity has occurred on that page. They've scrolled, they've moved around, so they probably read something, so they've engaged with it. You can also understand the entire time they were engaged on this page. What's interesting is if they stop, or maybe they move to another tab, if they, I don't know, shut their computer down for the evening, whatever, and then they come back to that page, the heartbeats start again. So you can almost count up how long, by knowing how many heartbeats they've been engaged with this page. So if they've got 2 heartbeats, that might be 10 seconds of engagement, a gap, and then a couple more heartbeats, that might be another 10 seconds of engagement. So your total engagement now is 20 seconds on this page, but in sort of 2 separate moments. And we also track how far up and down and across, if you've got horizontal scroll on the page through these heartbeats as well. So as the user's scrolling up and down, we're keeping track of their max and min scroll depths. So you can understand how much of your content's been engaged with, like how far down the page they've got. Now that's happening at the raw event level. So if you imagine each of these dots as an individual event, 1 page view, 4 heartbeat events, that's sort of cool, but quite hard to reason with in its raw event format. So you need to aggregate that information. So what we end up with at the page view level is an engaged time in seconds. And you don't have any concept of a heartbeat event in the page views table, but all the information that the heartbeats have given us is aggregated up into that page view. So we know that there's been 20 seconds of engagement or 25 seconds of engagement. We know that they've scrolled a certain amount, and we know that they've clicked at least once on the page because we captured 1 click event for that page view, et cetera, et cetera. You're aggregating that up. That makes the query super easy because now you're doing select engage time from page views where user ID is whatever, or where page URL is whatever. You're not having to write CTEs to look at all the heartbeats to then pull that into the query every single time you want to consider how engaged users have been on a particular page. The aggregated view just makes the query so easy. So that's really the power of that aggregation. But beyond aggregation, going incremental allows us to basically make sure that these models continue working forever. As your table grows, your events table, you can't just keep dropping and recomputing it. It just doesn't work. So a drop and compute model might look something like this. On the left, this is from the Snowplow DBT package. And you might select some properties from the page that are page views. And then you want to calculate, I don't know, within a session, which number page view was this? So this user went on 1, 2, 3, 4, 5 pages, and we order them basically on the timestamp that the user went onto those pages to get an ID or an index for each page view. Now, we could recompute this table every single evening if you wanted to, but if we're dealing with 50 billion rows, all of a sudden that's probably quite expensive. So instead, we built something a little bit more complicated. We first try and find which sessions have new events since the last time we ran. So we look at the timestamps, the last timestamp we've seen, and we check if there's been any new events since that timestamp. If there has, then we look at that session, we capture all those session IDs that have had new events, and then we basically can recalculate those, and we can incrementalize that logic, and we can then upsert that if we want to. So a few little caveats here, or a few little things to watch out for, and that I'll just finish with really. If you want to incrementalize data models rather than dropping and recomputing, ensure you are filtering in your incremental logic on the actual partition of the data. So in Snowplow, there's now three actually timestamps that people may partition on. So we used to recommend derived timestamp. That turned out to be a bad idea for various reasons that I only have a minute left, so I won't go into. We recommend collect timestamp, but we've just introduced loaded timestamp, which may actually be an even better timestamp because that's the exact moment that event landed in the warehouse. You also want to restrict table scans on all source tables if possible. And so not just your base events one, but any table that you're scanning, and try and reduce the table scans that you can do there. So here, rather than scanning the entire sessions table, the entire events table, we're only going to scan back 3 days. Now, this is a limitation, right? But we're now assuming that a session cannot have new page views in it if the session was 3 days ago. That session's clearly ended. In all circumstances, that session must have ended. All the events will have landed in the warehouse by now, even late arriving ones. So we can safely say there's no point looking back longer than 3 days. So I'll just limit that collected timestamp look back for 3 days. Nice win there. A massive win, actually. And lastly, really understand your warehouse. Understand what you're partitioned on. Understand how your warehouse works, because there's little nuances to every different warehouse that you need to consider to ensure that you're being efficient. Consider the cost, consider the performance, consider when it runs, consider the size of your warehouse that you're running against. If you've got that sort of that tweak point in your warehouse choice, there's a huge amount of things to do. So these incrementalized models can get pretty gnarly. So yeah, understanding your warehouse is super important. And that's about it. So I've got a wrap up slide here. I'll just leave that on the screen. But ultimately, hopefully that was a little bit interesting to those of you who attended. And we went through how we built the tracking SDKs and why we handcraft them over auto-generate them, the differences in server versus client. We very briefly whipped through how to incrementalize a model yeah, how we deal with billions of rows and why the aggregation in those models makes doing analytics much easier. One thing I didn't really touch on was the configuration. The more configurable you make your trackers, potentially you then need to add support in your data models downstream for all that different configurability. And so if we add a new feature over here, some new default tracking that we want everybody to use, we now need to consider that tracking in the data model as well, so that we actually support that. And then it needs to be a toggle on and off because old versions of the trackers didn't support it, new versions do, all of that insanity. The schemas make it easy for us to track type-safe objects, and that's where we're exploring auto-generation right now. And then really understand your entire pipeline, your warehouse, your trackers, your data models, what's happening inside the pipeline, so you can deeply understand where your data is coming from and where it's going. And that is a wrap. So thank you very much. I'll loiter around for any Q&A. But yeah, thank you very much for attending. Enjoy myself. Cheers. All right, can't see any questions, so I'll head back to the lobby and I'll see you all there. Thank you very much. Bye-bye.